In this video, we're going to take a look at constructing or drawing the graph of the function sine of x. So what you see in front of us is just a blank set of axes. We'll say this is the x-axis, x being the input for the sine function. And those x values are going to turn out to be our arc lengths. And so we're going to be adapting everything we know from the unit circle onto this graph, which notice has no circle on it. So these graphs will be very related, the unit circle and sine of x, but look quite different. The first step in the process, for now, this is just the basic parent function sine of x, is going to be for us to mark off the axes and just kind of get the frame set so we can draw this graph well. So what I'm going to encourage you to do is, let's label things. I already have the x-axis labeled with the letter x all the way on the right side there. I'm going to label the value of 0 for x right at the origin. And then vertically, of course, we have the y-axis, which I'll label up there. Now, I'm going to start by graphing just one period of sine of x. And then we'll see as we gain the habits or the skills to do this, that you can graph any number of periods as you like. We probably won't graph more than 2 periods. It just gets a little repetitive, as you'll see. But let's start by just graphing one period. And if you recall, the period of sine of x is, that's right, 2 pi. So all the way down the x-axis here, I'm going to mark off the location that would be one full period, 2 pi. Now, most of the work in graphing these by hand, which is what we'll be doing for most of this, is just setting up the axes so that you have all the right markings on it. So what I'm going to suggest is that step one would be to go all the way to the end and label the length you want to go for your graph. So if I said 1 period, that would be 2 pi. Now, once you get the full length labeled that you want to graph, whether it be 1 period or 2 periods, you want to then just cut that in half. Okay, so if this is 2 pi, half of it would be, well, 1 pi. And that gives us 2 pieces now on this axis that I want to cut in half again. So halfway between 0 and pi, we have, of course, pi over 2. And then halfway between pi and 2 pi would be 1.5 pi, which we now know as 3 pi over 2. So all of our same special fractions and special arc lengths are now coming right off the unit circle onto our axes. Now, just for fun, I'm going to cut each of these spaces you see on our graph now in half again. So halfway between 0 and pi over 2, of course, we'd have pi over 4. Halfway between pi over 2 and pi, we'd have 3 pi over 4. And you might recall that what I'm doing now is just counting by fourths. 0, 1/4 pi, 2/4 pi, that's really 1/2. 3/4 pi, 4/4 is 1. So what's next? That's right, 5/4 or 5 pi over 4. 6/4 is 3 pi over 2 reduced. And then 7 pi over 4. And then 8 pi over 4, which is 2 pi. Those are our familiar special fractions, special arc lengths, all that good stuff. But now just put on the plain old flat horizontal x-axis. Now, you'll hopefully notice that we are missing some of our special fraction arc lengths. In fact, I did not put some of the sixth fractions on here. For instance, pi over 6 would be here. Pi over 3 is the next value. That'd be somewhere over here. Okay, so those values I haven't put all the way down, but in fact, just for simplicity at the moment, I'm not going to put them all on there just to keep it from being too cluttered at this point. But I think we'll start to see how they would show up and matter. And now on the y-axis, here's how we're going to fill in those values. I'm going to start by marking off the top and bottom of our graph, which will all correspond to the y-coordinates of the terminal points on our special arcs of the unit circle. So we know that the highest y value you see for all those coordinates is +1, and the lowest, of course, is -1. Now, everything else is somewhere in between those. For instance, we know that +1/2 shows up, so I'll put that there. Of course, -1/2 is also on there. And then the others, which are kind of nasty as far as numbers go, remember we have a root 2 over 2, a root 3 over 2, and those find their places on here somewhere. I'm going to see if I can put them on neatly enough. Root 2 over 2 turns out is 0.7-ish, rounded. So if 1/2 is 0.5, of course 0.7 is somewhere up in here. So I'll label that root 2 over 2. And then root 3 over 2 is a little bit above that. As a decimal, it's about 0.87. So again, I'll label that carefully here, root 3 over 2. You can tell these get cluttered quickly, so I'm just trying to keep it at the basics here. We'll not put any more on there, but I want to put some of the negative corresponding values. So at least the tick marks, right? So this is negative 1/2. Below it a little bit would be the negative root 2 corresponding to the positive root 2 over 2. Down here would be the negative root 2 over 2. And then a little bit below that would be the negative root 3 over 2. Okay, so we just need to know where those places are. Our goal now is to know the unit circle well enough to know how all of these arc length values that are plotted on our x-axis relate to all of these sine values or y-coordinates that are now plotted on our y-axis. All right, let's give this a try. The sine of 0, or the y-coordinate when the arc length is 0 is, yes, 0. At pi over 6, the y-coordinate is, think about it. If you need to, redraw the unit circle to make sure you understand these. But the y-coordinate of pi over 6 is 1/2. So we should have an output place right there. I'm just putting dots at these places where they all line up for now. At pi over 4, when the arc length x is pi over 4, the y-coordinate at that terminal point is root 2 over 2. So that's over here labeled on our y-axis. I'm going to put a dot where that location is. At pi over 3, our output is root 3 over 2. For the y value, I'm going to put a dot up there. Again, lining up vertically here with our root 3 over 2. And then at pi over 2, which is the very top of the unit circle, our y output is 1. So I'll put a dot up there where 1 would be. Now, the symmetry of the unit circle is going to make our lives way easier here. In fact, I'm not going to keep going through. I did a lot of extra tick marks here right away, but I've now spaced them out a little bit. Remember, I only put the 6th marks here at the beginning. I didn't fill them all in here the rest of the way. That's just for simplicity. So let's plot in the rest of these that we have. At 3 pi over 4, our output is root 2 over 2 again, lining up over there across the first one we plotted. At pi, the sine of pi, the y-coordinate at pi is 0. Yep, so a dot there at 0. At 5 pi over 4, it's back down to negative root 2 over 2. Okay, so again, that's lining up horizontally with that value. At 3 pi over 2, which is now at the bottom of our unit circle, the y-coordinate there would be negative 1. So we'll go all the way down here to negative 1, lining up with that horizontally and put a point. And then you can probably get the idea of how this pattern goes. At 7 pi over 4, it's back up here to root 2 over 2. And then at 2 pi, the sine value is back to 0. Okay, now if I connect all of these dots with a smooth curve, we end up with something like the following. Which is exactly what our sine graph looks like. Now, my picture's not pretty. A computer does a much better job. But it shows you at least the mechanics of how to generate this graph. Again, this is the sine function, only one period of it, though. Let's now take a look at the same function, y equals sine of x, but this time, let's see if we can graph 2 periods of the function. So again, we'll have our blank axes here with a 0 at the origin. We have our x-axis extending out horizontally, our y-axis vertically. If one period of sine is 2 pi, then 2 periods would be, you guessed it, 4 pi. So I'm going to go all the way to the end of my axis on the right, and label the 4 pi location, which is as far as 2 periods of our graph, which is all I want to put on here. But the process of graphing 2 periods of sine is not much different from graphing 1 period of sine in the following way. If we can set up our axes, we're good. So if I have 4 pi all the way to the right, indicating the end location of 2 periods, each period being 2 pi, then I'm going to cut that in half. So halfway between 0 and 4 pi would be, that's right, 2 pi. I'm going to cut each of those pieces in half now. So between 0 and 2 pi, halfway would be pi. Halfway between 2 pi and 4 pi would be 3 pi. So we're just setting up our axes with all these markings by cutting things in half. Really, that's all it is. So then I'm going to cut each of these in half again. Between 0 and pi, I have, of course, pi over 2. And at this point, we can start using all of our counting tricks by fractions that we've been doing with the unit circle. So watch. We have from 0, we're counting by pi over 2 here to get 1 pi over 2. 2 pi over 2 is 1 pi there, already labeled. Next would be 3 pi over 2. Then 4 pi over 2, which is already labeled as 2 pi. Then 5 pi over 2. 6 pi over 2 is 3 pi, 7 pi over 2, and then 8 pi over 2, which is 4 pi. So remember, from 0 all the way down to 4 pi, that's going to represent 2 full periods, each being a length of 2 pi, and we're going to graph sine for this entire length. Now, it's always good to start with the basics that are easier. For instance, where do the sine values hit 0? Okay, so think back to the unit circle. Let's sketch one here real fast. If I have the unit circle, right, this is like our dream up in a cloud somewhere, okay, what we remember. The unit circle has a whole bunch of points around it. I want to know where the sine value or y values are 0. Well, that only occurs right on the x-axis in 2 places. That would be 0, or the next place over here is pi, but then I could get back around here to get 2 pi, okay? So let's plot those 0 places. I have sine is 0 at 0, it's 0 at pi, and then again at 2 pi, and then again at 3 pi if you just keep whirling around the circle, and then again at 4 pi. All right, so we've plotted all the x-intercepts for us, understanding the unit circle and the y-coordinates, which are the sine values of all those special places. Now, let's see if we can also find where the sine values are 1 or -1. Those are some key places too. So again, just think of the unit circle, pull it out real fast. The sine values of the y-coordinates are 1 at the top and at the bottom. So all we have to do is recall where or which arc values would hit there, no matter how many times we rotate around the circle. And you'll recall it hits at the top, it's pi over 2, and then at the bottom, it's 3 pi over 2, and it'll just keep looping around to those. So at pi over 2, the output for the sine value, which is the y-coordinates on the unit circle, is +1. Okay, at 3 pi over 2, the output is -1. That's the bottom of the unit circle. Okay, we just kind of keep cycling through this. At 5 pi over 2, now that's beyond one wrap of the circle, but that's okay, because the pattern continues. I go from 0 up here to 1, trace it back down to 0, down to -1, back up to 0. What would be next? Well, +1, then 0, then -1, and then back up to 0. So I can trace the rest of these points if I just keep the cycle going. There we have it. This is the sine graph because we've generated all of these outputs being 1 or 0 from the unit circle where the sine values are the y-coordinates of the special points. And this is a full 2 periods, which goes from 0 all the way to 4 pi. It's not always necessary to put more on the graph than you're seeing here. For instance, I know there are plenty more places on the x-axis that we could mark off, such as pi over 6, pi over 3, 2 pi over 3, all these other things. You can put those on there. It just gets more cluttered and it's unnecessary. All we really need to do is take the graph out as far as we want to go, which in this case was 2 periods or 4 pi, and then just keep cutting things in half as we did, so that we get a plenty of the common places, such as the high points, the maxes, in this case 1 down to -1, the low points, and all the x-intercepts. And we're going to learn to adjust these graphs as we go. We can stretch them, shrink them, flip them, all kinds of things. Now, with that being done, the graph of sine of x here, and now done with 2 periods, I want to see if you could figure out how you might do this same thing, the exact same thing, with cosine. Same process, different function, some different values. Think about how you might accomplish that.